Thank you, Dr. Carey. It's been very enjoyable so far. Very nice session. And of course, the musical introduction was wonderful. For me, it was a first to be invited by a world-famous jazz rock musician. It's never happened before, so thank you. Thank you so much. And I don't have any financial relationships to disclose. And I'm not going to discuss any off-label use. So the talk objectives are right here. They're in your syllabus. And I'm going to go straight into my particular talk. So down here I have a southern blot, and Dr. Carey gave a very brief introduction to the history. This was an amazing tool for discovering viruses. And human papillomaviruses are a very large family of DNA tumor viruses. They're small DNA tumor viruses. Some of them are drivers of carcinogenesis, but most of them are not. And the way they were named was chronologically. HPV-1 was the first virus extracted from a plantar wart. HPV-6 actually was cloned by Lutz Giesmann in Harold Zerhausen's lab in the early 1980s. And the next one, HPV-11, was also cloned by that team. And these viruses don't have any aggressive E6, E7 genes. They don't promote an aggressive cell immortalization. In the early literature, and sometimes people will find them in cancers, and they can rarely, in the presence of other genetic mutations, end up in strange kind of locally invasive warts, so-called Buschke-Lowensteins in the German vernacular. But the first carcinogenic virus, of course, was HPV-16, cloned by Matthias Durst in Professor Zerhausen's lab in 1983. And it's the most common virus. HPV-18 was the next one in line, and that's more common in adenocarcinomas, although it's fairly common in squamous as well. The 18 virus is more of a sneaky character because it does occur at younger ages, and it does tend to skip CIN3, so it's not detectable as easily. And I cloned HPV 31, 35, and a whole bunch of other HPV types, which led to the cocktail of HPVs, which we really require for early detection. And this shows an electron photomicrograph with the small viral particles within the nucleus of a particular cell, like a chyliocyte, and the genetic organization. This is a simplistic version of the genetic organization. And the E6 and the E7 genes are the really nasty genes as far as the promotion of carcinogenesis are concerned. And I'll tell you a little bit more about that. So if we look at a typical infectious process, it takes many months to play out. You know, there's typically a silent period after infection where nothing is seen. In fact, in most cases, nothing is seen because if you have sustained clinical remission and, in fact, an occult infection, you'll only detect the DNA, but you won't see the effect. So if you see an active growth, it can be a flat lesion, it can be a wart, many different kinds of morphological manifestations, and then there can be a host containment period. As I mentioned, you may not have any active growth, and the virus may be in the skin, in the basal cells, just replicating very quietly, and you can only detect it by molecular methods. Now, over here we have the late stage, which is typically reached after 9 months to a year. And there is occasionally persistence and rarely cancer. And that's for the high-risk HPV types. Now, in immunocompromised patients, the ball game is different because they will have persistence of many different kinds of viruses, including non-carcinogenic ones. But for most of us immunocompetent people, most of the viral DNA goes away completely. And it's the ability of the virus to become persistent that is a step in carcinogenesis. You've seen this diagram before from the previous speaker. And generally just divided into the late region for the viral capsids, the early region, there's a number of different proteins, and of course the origin of replication and the promoter region, the so-called upstream regulatory region. E6 binds P53. And E7 binds PRB. This has been known for a long time. These proteins do a lot of other things. This is a very classical understanding. And what was also known for quite a while, of course, is the fact that integration occurs into the human DNA, but don't get carried away with integration because often cancers don't have integration. The majority of them do. You can have both integrated and episomal copies. And there is a different molecular manifestation of the different viruses. HPV-18 in a cancer, you will find virtually 100% integrated. HPV-16 tends to be about 80 to 90% integrated, and some of the other types like 31, 35, you may only find 60 to 70 to 80% integrated. So there's definitely only episomal cancers as well. However, if we look at E6, sorry, I have to go back, and I'm not sure how to do that. Oh, here we are back. So what you'll see is the E7 and the E6 block the tumor suppressor genes, and what that leads to in a simplistic sense is immortalization. So again, this might be an unfortunate concept because it's a cell line concept. A cell is regarded as immortalized in cell culture if it can be grown indefinitely. However, if you grow it indefinitely, it definitely accumulates lots and lots of other mutations. And the other point is, inside the body, an immortalized cell is blocked. It can't actually go anywhere. So cancers evolve within us to suit our particular environment. And immortalized cells are definitely not cancer. They're very far away from it. However, they have a potential to grow for a long time. The cell cycle is deranged, but the differentiation pathway is not necessarily deranged. So thinking back to E6, E7, what they do is, if there's major DNA damage, you have apoptosis through the P53 and other pathways. E6 and E7 interfere with that, right? If you have minor DNA damage, you would have genetic repair. E6 and E7 interfere with that. And what they do is they drive the cell cycle progress, interfering with retinoblastoma and also with P53. However, there's a lot more required. There's something missing, and the model never anticipated epigenetics. And what we're finding is that, in fact, epigenetics is an incredibly important process that goes on and may, in fact, be the biggest driver at the precancerous stages. So, yes, E6 and E7 act on PRB and P53, and then you need a lot more. Now, DNA methylation is important for normal development, chromosomal integrity. So, in fact, chromosomal instability is directly manifested upon by methylation. Hypomethylation leads to mobile elements moving, transposons, viruses becoming mobile, and in fact chromosomes becoming sticky. So abnormal methylation does lead to chromosomal instability. It's involved. And silencing, of course, of foreign DNA. This is a simplistic scenario, but I think it's good enough for you at the moment to really take away, because you'll see this in the literature that if a gene is highly methylated, the genes may be turned off, And if the gene is unmethylated, it may be on. But in fact, that's not all there is to it. There are things called poised chromatin. In other words, genes that are ready to be transcribed, but they're not, because other transcriptional factors in other environments are not suitable for it to be transcribed. And then there's the whole microRNA machinery as well. So putting it all together, genetics and epigenetics, of course, our entire bodies are patterned from a single fertilized cell, and it really isn't entirely an epigenetic event. What happens is you have different regions silenced for efficiency, and for example, neural cells come from the same stem cells that epithelial cells come from. And if you think about just abnormal events shown in red and a normal epigenetic event shown in green, there are two possible states when you start leading up to CIN, which is a normal epithelium that is infected with an HPV, or an epigenetically abnormal epithelium that is infected by HPV. And this can underpin the more rapid development of CIN3 if there's already a poised, epigenetically prepared abnormal epithelium and you have an HPV infection. The progress can be much more rapid than if that person is resistant. So the genetics, the inherited genetics of the people actually play into how susceptible they are to a rapidly progressive disease versus not. And of course, once you come down here, you get driver mutations, and these would be your indels, your SNPs. They don't play as big of a role up here, but they play a much bigger role down here. And then, of course, in the plasticity of the cancer genome, which actually evolves to fit every niche it comes across and to ultimately respond to any drug that is given to it. So thinking about HPV infection in terms of a couple of different buckets, it's useful to think about it as the first carcinogenic step. Although it may not be, because my previous graph, I suggested that epigenetic events could actually be the first carcinogenic step into a poised and at-risk state. If you have a high-risk HPV infection, it will typically lead to three general groups. The infection will regress, the infection will not regress, and there's going to be prevalent CIN3 discoverable, so that's CIN3 or invasive cancer, or elevated future risk of CIN3. In other words, the person may have an LCIL, or they may just have a persistent HPV-16 infection, and it's there for years and years, and later on, something develops. And of course, this is the most difficult group clinically, because these are very anxious patients, can't tell them what to do at the time. A very interesting study from Lynn Denny, published in JAMA, showed that if you treat morphologically normal women with persistent HPV, it does prevent future CIN3+. And that was a study done in Africa, so in South Africa. So it shows that you can, potentially if there's a very anxious patient with a persistent infection and they are willing to undergo it, a treatment can actually prevent a CIN3. And it turns out to be quite effective. Okay, so one of the large pieces of work that I did, which was published in 1992, divided the carcinogenic HPV types generally into two groups and a low risk. So there's three general risk groups of viruses. Subsequent researchers actually missed this. Even the New England Journal of Medicine paper in 2003 by Munoz et al., where all high risks were classed into one group. But in fact, the most aggressive viruses are 16, 18, and 45 for adenocarcinomas, squamous carcinoma, and even among the intermediate risk viruses, 31 and 33 are more aggressive than the other types. So even within that, you could say high risk intermediate, low risk intermediate. They are actually all quite different in terms of their risk and how long you might have persistence, before the malignancy occurs. So, kind of recapping, more than 200 known HPV types. The high-risk types are the following: 16, 18, 31, 33, 35, and on up through here. HPV 66 is found in some of the PCR kits by Roche and by Abbott, but 66 actually is not a high-risk type. It's a low-risk type, and there's a little bit of an issue on that. And these are the two main papers, Munoz et al., 2003, and my paper in 1992, really defined these groups. And I think the original 13 that I defined are really the 13 that we need to test for. Okay, so the philosophy of cervical cancer prevention by HPV, why does it work? It works because most cervical cancer starts as a 10-year infection. As I mentioned, sometimes it can be quicker, and we do see cancers in teenagers, cervical cancers, and in women in their 20s, and you know, they may have got it earlier or whatever. There's occasionally faster progression, but generally this would be the case. And generally HPV negative women are safe from the disease, although not 100% of cervical cancers are HPV positive. That's again kind of being rethought a little bit. And this is a ViraPap test, which was FDA approved in 1988, but just shows you how long ago it was, but that went by the wayside. Mark mentioned the hybrid capture 2 test, and this also has been superseded by the PCR tests. It's still being used in China and in other places, and this is a signal amplification test. Whoa, looks like our computer is going to go off if somebody doesn't plug it in at the back. Okay, that's hybrid capture 2. PCR, as I mentioned, has become the primary test. And this shows you that most of the PCR testing occurs in the L1 region, which is the late region. Certainly the COBOS primers, the SPF primers, these are research primers for epidemiology. They create very small amplicons, but you'll see them in the genetics test, the lipid test, for those of you who might be doing research. And they're super sensitive, but you have to be careful because they will find HPV in lots and lots of places, even at 5 or 10 copies. Definitely not good clinical utility, but great epidemiological utility. There are some PCR tests that are out there now that are looking at the early regions. The BD test is one, and there are other tests that are coming along. And they don't suffer from a limitation of occasional negativity due to deletion of the L1 region. Okay, so what are the data underpinning the clinical value of HPV testing? This slide actually summarizes a large number of randomized clinical trials, and they show that all of these different researchers found, on average, a relative risk of about 1.7 versus cytology for detecting CIN2 in the first round. So what this graph is telling you is that, on average, HPV testing is about 50 to 70% more sensitive than cytology for screening. And that turns out to be a pretty important point. The protection offered by HPV is also much greater, about twofold as it turns out. This actually shows you the cumulative incidence of CIN2 plus over a period of 12 years. And this is a summarized set of studies published in BMJ. And if we look, if we look at the highest protection, it's afforded by a control arm, cytology and HPV negative. It's shown by the green solid line. And if we show the least protection, it's by cytology negative. So if we look here at about 8 years, the risk of CIN2 plus after 8 years is about 0.5% with HPV testing, but it's about 1.4% with cytology. So in fact, what this says is that you can do much longer screening intervals with HPV and get the same protection as you would with cytology. Theoretically, you could do a 9-yearly screening interval with HPV and get the same protection as you would with a 3-yearly interval with cytology. Really quite powerful data, I think, in terms of, because screening is not being very well received, and acceptance by women is actually going down. It's reaching a very low level in the UK in many places, or perhaps because of, changing perceptions. Now, if we look at one final point, HPV screening protects or reduces cervical cancers by 50% versus cytology. And this is Ronco et al. So HPV detected 7 cancers in the first screening round and 0 cancers in the second screening round. So as compared to liquid-based cytology, which detected 9 in the first screening round and 9 in the second screening round. So presumably what happened here is there were no cancers in the second screening round because all of those CIN23s were treated in the second, having been discovered in the first screening round because it was more sensitive, and therefore there was a reduction in cancer. And this was, these were 3-yearly screening rounds, so it was baseline first screening round, and then 3 years the second screening round. Advantages and disadvantages of HPV DNA testing. There's always 2 sides to the coin. HPV DNA testing is much more sensitive than cytology, and it's actually less expensive now. It turns out PAP is more expensive once the costs are being correctly allocated, given the automation of the HPV testing. 95% sensitivity versus 60 to 70%. However, HPV specificity is much lower, only about 80 to 90% versus 90 to 97%. And since we need to minimize women on repeat follow-up, we need an efficient triage. And that is, I think, the current crux of screening programs worldwide. What is that efficient triage? And there are a number of possible tests around. Of course, cytology can be a triage. Read with prejudice, you know the HPVs there. P16, Ki67, and of the molecular tests, which don't require a microscope, HPV 16, 18 genotyping, and DNA methylation, which is what I've been working on. Have a look at this, because this is the 2005 JNCI study, and it shows you how important it is to follow up these people because the HPV 16 positive individuals had a cumulative incidence rate of about 15%, as opposed to the HPV negatives, which were only about 2%. And in fact, this slide was slightly out of order because I wanted to introduce the triage. This is another reason why following HPV infection is so important. You can see that 18 and 16 lead the pack, but the HPV other types are also very important with a greatly delayed. So the cancer, the CIN3 pluses in those women start to appear, 10, 12, 15 years down the road. All right, methylation of HPV and host DNA. This is a study that I did with Eduardo Franco and Carolina Levanto from Finland, where we showed, and this is from the BCCR study, which was done in Montreal, Toronto, Quebec, these areas, and 2 genes, HPV 16, L1, L2 is what we tested by methylation, and EPB41L3, which is a human tumor suppressor gene, and it's in one of the differentiation pathways, the Wnt pathway. And as you can see, going from normal to cancer, there's a dramatic increase in methylation, both for HPV 16 and also for EPB41L3. So we see this trend pretty universally in lots and lots of different populations. And we looked at a methylation classifier. I developed a classifier called the S5. And this is only for research use at the moment. This is in the UK. And this shows you a ROC curve, which is simply plotting sensitivity versus specificity, or if you will, in a sense, the true positive rate versus the false positive rate. And the perfect test is going to have an AUC of 1, and it's going to be right over here. So this is HPV 16-18 genotyping, had a sensitivity of only about 58%, and had a specificity of about 70%. But the EPB, the S5 classifier was much closer to the upper hand quadrant and had a high area under the curve of 0.84 for CIN3+. So it's actually working as a significantly improved classifier for women who are HPV infected. Okay, so that kind of brings us to the end of the talk. And I think there's also, I gave a group of questions, and I think I indicated that maybe they could be coded here.
Mm-hmm.
So
I think they're right at the end here.
they're right at the end. Are they? Okay. So large family of DNA viruses. HPV-6 was the first anogenital virus. HPV-16 was the first carcinogen. They are typically transmitted as an STD. Some may persist for decades and become malignant. Important take-home message there is that, in fact, it's a very small percentage of people who are infected with high-risk HPV types who eventually develop cancer. But the reason there's still a lot of cancers is because the infections are very prevalent. E6 and E7 are the primary drivers of immortalization. They're not the primary drivers of cancer. So you need to keep that separately in your mind. And HPV DNA testing is the most sensitive screen for cervical precancer, but has low specificity. And triage at the moment includes cytology, repeating HPV testing, 16-18 genotyping, and eventually methylation when that happens to come along. And I think question 1, okay. So select the subgroups of high-risk HPV types in the current screening kits. Which ones are they, okay? And it's...
Just give them a minute to...
Give them a minute,
just a second
okay.
to answer, and then I'll bring up the...
And so the next slide will show the answer. Is that the way,
Yeah,
is that the way you
that's
coded it, okay? I'll give you guys a minute. Okay, well, we got 80% and 20%,
Sure.
and in fact, the 20% people had it because HPV 34 is not part of the kit. That is a low-risk virus. It's a EV. So sorry, maybe a trick question, and it's hard for you to all remember that from my talk because it went fairly fast, but question 2. Okay, sorry, question 2. Okay. Okay. Which example is a key host protein directly targeted by HPV-16? And I think we have the answer already, and of course, and not of course, but okay, we're going up to 89, 90. Okay, that's it, I think, that's the answer.
Yeah.
And the, it's not going forward. The correct answer is P53.
They'll take the...
Okay.
Yep.
I gave 4 questions, but I
Yep.
think you only coded 2, did you?
I'm not sure. They have them at the back, so
Okay.
you can keep going.
P53 is the
Yep.
answer. It is targeted by E6,
Yeah,
and there it
you go.
is.
Yep.
That's right.
Yeah,
Very important anti-apoptotic protein, so that's an important
They
one.
run through them at the back now, so the questions... Is there another one?
There may-
Yeah.
Is that the last
no,
question,
here it
guys?
is here. Yep,
Okay,
question three.
question
Yeah,
three.
I'm going to
Sorry.
run through that.
I was tough. I gave you more than 2 questions. So
Are
sorry.
we okay?
What is the target molecule of the main HPV DNA test? Sorry, there's a question?
Cervix wants to say something.
Oh, apologies, yes.
No, sorry, you should just wait before pressing so that he can control the...
Oh, I shouldn't press at all.
Right, yeah.
Okay,
Okay,
that's all right.
sorry. Better if the expert does it, you know? I get carried away with these things. Okay. And it's DNA. And there's, in fact, only one test, Aptima, that goes for RNA. All of the others, over 100, go for DNA. And there's one that's defunct, which is called a NOR chip, but you may not know about that. Okay, so the last question.
He'll bring it up.
Question 4.
Yep.
Should I press? Yeah, okay, question 4. Here we go. Select a currently acceptable triage for an HPV positive woman. Okay, and it's HPV 16/18 genotyping. Methylation is not approved anywhere, although it is CE marked in Europe, so it can be used there. But I think for a Canadian audience, that doesn't work. So thank you very much.
That's great, thanks. We have time maybe for a question or two, but we do have a reception, and please feel free to stay to speak to the speakers if you have questions afterwards. I've got a quick question, if nobody else does. So the mechanism for oncogenicity then is still not clearly understood because we're genotyping the virus on the basis of the capsid protein. And I mean, you were saying that it may be something to do with the predisposition of the cells before the infection, or is there some biologic difference between the E6 and E7 proteins in the different HPV types?
Well, we're genotyping the viruses on the basis of the DNA encoding the capsid protein because that happened to be a convenient place to design PCR primers that detected all of the viral types. It's not that that's a particularly important molecular feature. All it tells you is that 16 is there. And then you say, well, 16 is an aggressive virus. The carcinogenic steps are not fully understood, but I believe that measurement of methylation does give insights into the risk of future cancer, and we've shown that, and I'll give a little bit of that in my talk tomorrow. Mm-hmm. In fact, it can predict risk of disease because you can actually measure the levels of it. Just actually testing for P53 or testing for PRB is not diagnostically useful because they're just there. The virus interacts with them. It immortalizes the cell. So what you'd have to do is measure some other aspect of immortalization. And what is that? There's not a lot of genetic changes. So actually a signature of in situ immortalization is enhanced methylation of certain genes and including of HPV. So that is actually a signature of the immortalization step. And then there's a few additional steps that are required for the invasion to occur. Because you can see that in SYN3 and SYN2 as well.
Right.
Yeah.
Thanks.